Hello there, Charger family. This is Mrs. Boyd at Mrs. Boyd's Math Room. Thank you for joining me today, where we're going to talk about absolute value equations. It's going to be absolutely amazing. Hope you're doing amazing. Absolute value is the distance. Holy cow, the distance from 0 on a number line. And it's always positive. It's kind of like the distance from when you're going somewhere. When you come from home to school, maybe you drive 5 miles. When you drive from school to home, you don't drive -5 miles home. You drive 5 miles just in another direction. But we still say it's 5 miles. So that's how absolute value works. So the absolute value of 4 is 4. The absolute value of -4, the absolute value signs make this a positive number, and that's actually positive 4. Now, we're going to look at this separately. So the absolute value of -4 is positive 4, but this extra negative out in front doesn't go away because it's not inside the absolute value. So the absolute value of negative times the absolute value of -4 is, let's rewrite this a little bit differently. It's like saying -1 times the absolute value of -4. So that's -1 times 4, which is -4. Okay. How to evaluate an expression. Substitute the value in for the variable. So let's write it in here. If we've got 2 times the absolute value of 3 minus x plus the absolute value of x, if x equals -2. So we've got 2 times the absolute value of 3 minus -2 plus the absolute value of -2. We substituted it in. Now, simplify the absolute values. Well, that's 2 times the absolute value of 3 plus 2 plus the absolute value of -2 is just 2. That's 2 times the absolute value of 5 plus 2. Well, the absolute value of 5 is just 5. Then simplify the expression. 2 times 5 is 10 plus 2, and 10 plus 2 is 12. And that's our answer. We still use the same order of operations that we would if there were no absolute values. The absolute values are just another kind of grouping symbol. All right, let's do some more. We've got x is -1, y is -2, or y is positive 2, and z is -3. Let's plug some values in here. 10 minus the absolute value of 5 times -3 plus 3. Well, that's 10 minus the absolute value of -15 plus 3. That's 10 minus the absolute value of -12, or 10 minus 12, which is -2. Same thing on the next one. Absolute value of -1 minus 2 plus 6. Well, -1 minus 2 is -3. The absolute value of -3 is 3, and 3 plus 6 is 9. The last two are yours to try. Go ahead and pause here and try them on your own. All right, we've got the absolute value of -2 times 2 plus -1 plus -3. It's a lot of simplifying we got to do. So -4 minus 1, absolute value, minus 3. Well, that's -5. Absolute value of -5 minus 3, or 5 minus 3, which is 2. Then we've got 3 times the absolute value of -3 minus -1 plus 2, or the absolute value, sorry, I got that in the wrong spot. Absolute value of 2 minus 2. well, let's start at the left here. 3 times the absolute value of -3 plus 1 plus the absolute value of 0. That's 3 times the absolute value of -2. And plus 0 kind of just disappears. So we've got 3 times 2, which is 6. So those are absolute value expressions. Let's flip over and look at absolute value equations. First step is going to be to isolate the absolute value expression. We want to get the absolute value all by itself. So in this case, we're going to add 3 to each side and have the absolute value of x minus 5 equals 10. Now here's where it gets crazy. Create 2 equations, one set for the positive value and one set for the negative value. So that means we're going to say we could have x minus 5 equals 10. This is where the absolute values go away, by the way. Or we could have x minus 5 equals negative 10. We say this because we don't know on our number line if we're going in the positive direction or the negative direction, because the absolute value takes that specification away. So now when we're going to solve an equation, we have to account for both possibilities. So let's solve these separately. We add 5 to each side on the left, and we get x equals 15. We add 5 on the right as well, and we get x equals negative 5. So if we're going to graph these, we're going to put, you know what? All I care that you put on here are the 2 points that you're caring about. So let's do, here's one at negative 5. It's going to be a filled in dot. And here's one at positive 15. And it's also a dot. Okay, we're going to represent our solution a little bit strangely here. X equals this little squiggly thing. This represents a solution set. So our solution can either be negative 5 or 15. That is the answer, including the graph that we did. Let's try another one. We don't have to isolate the absolute value. It's already isolated, so we can go ahead and split it up into 2 possibilities. 3 minus 2x equals 7, or 3 minus 2x is negative 7. Let's solve the left. Let's subtract 3 from each side. We get negative 2x is 4, and divide by negative 2, x is negative 2. On the right, subtract 3, and we get negative 2x is negative 10. Divide by negative 2, and x is 5. So those are our 2 possibilities. We're going to represent our solution like that. By the way, when we're representing it in this solution set notation, your lowest number goes first. So we're going to have negative 2 first and 5. Those are the 2 possibilities. On our number line, we'll have negative 2 with a dot, and we have 5 with a dot. Let's look at some that are a little bit more exciting. 2 times 2g minus 3, the absolute value of 2g minus 3, minus 5 equals 21. We got to isolate the absolute value first, so we'll add 5. And we get 2 times the absolute value of 2g minus 3 is 26. We want to get the absolute value alone, so I'm going to divide both sides by 2. Those 2's cancel. We've got the absolute value of 2g minus 3 is 13. Now that the absolute value is all alone, here's where I can split it up. So I've got 2g minus 3 equals positive 13. And 2g minus 3 is negative 13. Let's solve these. We're going to add 3 on the left. We get 2g equals 16. Divide by 2, and g is 8. Add 3 again. 2g is negative 10. Divide by 2, g is negative 5. So let's do our solution notation. I'm going to do it up here. G is negative 5 or 8. And negative 5 and 8 on the number line. Let's look lastly here at p plus 6 equals negative 5. This one's going to be really easy. Can the absolute value of anything ever equal a negative number? No. So this is no solution. You could also do one of those. That means no solution as well. This is no solution because an absolute value can never have a negative solution. All right. This last part's my favorite, writing the equations. Oh, don't know what I did there. Let me see if I can fix that. So sorry. Ooh. All right. We want to, I follow these 3 steps. Step 1, calculate the midpoint or the average of the points. So the midpoint is going to be 6 minus 2 over 2. That's 4 over 2. That's 2. So the midpoint is 2. MP for midpoint. Find the distance from the midpoint to either endpoint. So we do 6 minus 2. That's 4. That's the distance from the midpoint to either end. Our equation, I gave you a little formula here. It's going to be the absolute value of x minus the midpoint equals the distance from the center to the end. Okay? It's really that straightforward. 2 more. First, find the midpoint. So here we have negative 7 plus 13 divided by 2. That is 6 over 2. That's 3. So 3 is the midpoint. The distance from the midpoint to the end is 13 minus 3. That's 10. So our equation is the absolute value of x minus the midpoint is 3 equals the distance to the end. Try the last one on your own, please, and then we'll be all done for the day. Okay, midpoint is going to be negative 16 plus negative 10 over 2. That's the same thing as negative 16 minus 10 over 2. That's negative 26 over 2, or negative 13. So right there's the midpoint. The D, the distance from the center to the end, is going to be negative 10 minus negative 13, or negative 10 plus 13, which is 3. That means our equation is going to be the absolute value of x minus negative 13 equals 3. Let's simplify. Absolute value of x plus 13 equals 3. I hope this makes lots of sense to you. You know how to get a hold of me if you have any questions or need any help. I hope to see you very soon.